Good afternoon and welcome to today's EuroSTAR webinar, NIMBLE, the next best agile method since sliced bread, with John Watkins. My name is Paul. I'll be the moderator for today's webinar. Before I hand over to John, there are just a couple of things I would like to bring to your attention. The webinar is being recorded and you will receive an email once it is available. The webinar will last for approximately 45 minutes and will be followed by a Q&A session. If you would like to ask a question, please type it into the control panel and I will ask it to John on your behalf. I will now pass you over to John.
Yes, indeed, Paul. Thank you for that. So good afternoon, everybody. Many thanks for attending this webinar. My name is John Watkins. I work at IBM as a client technical architect, but my soapbox subject is testing, as you may have guessed by now. Today we're going to be talking about NIMBLE, the next best agile method since sliced bread. So let's kick off the presentation straight away. Now, I'm having a slight delay in the slide changing. Here we go. Sorry about the delay. I should have tested it more thoroughly before I started this, shouldn't I? So, NIMBLE is an agile and fairly lightweight testing process. In NIMBLE projects, the startup and the close-down meetings and other talks in between are represented by common retrospective user stakeholder talks, or as we call them, crusts. Between the crusts, we have the slices, and of course the slices are what we use to organize our tasks in NIMBLE. In terms of how we determine the duration, the effort, or the cash involved in running a slice, we are actually going to be using a bread box technique to do that. As with many methods, if we don't follow a good process, then we're likely to find that major outage level defects will start to appear, or as we term it, mold. Pressing on to the method, quality control in NIMBLE involves collecting correlated requirements to use case mapping baselines, or crumbs. Once we gather enough of these together, we know that our NIMBLE slice is completed. If we have a sufficiently large number of crumbs, then that can be taken as an indication that we can progress on to the next slice and make progress towards the crust. As a final thought on this slide, we have to be very careful in terms of compliance and governance with the method. If we don't follow those properly, then we could find that the project becomes terminated on acceptance or suitability terms, or toast as we call it. Okay, so as hopefully most of you will have gathered by now, NIMBLE is a completely fictitious method. However, having said that, there are so many different agile methodologies and processes out there with some crazy names. Almost certainly since we started this presentation about 3 minutes ago, a half a dozen new ones will have already been invented and published, I'm sure. Okay, we'll press on. What we're looking to do today really is not to encourage people to reinvent the wheel again and again, but we're going to make a kind of a strong proposal that people should be looking to use tried and tested, if you will, existing and novel agile practices, rather than trying to just spend a lot of time running around creating their own methodologies. A lot of what we'll talk about today has been distilled out of some research I've been lucky to do over the last, I suppose, 6 or 7 years, where I've looked at real-world agile projects, spoken to practitioners on those projects, and collected their experiences together. And hopefully that information will be valuable for yourselves on your own projects. We'll finish off with summary and conclusions. All the way through, you'll see at the bottom of this page, we'll be having a few quotes, which I think are either appropriate or cautionary. This one was something that one of my colleagues said recently. I've heard Dorothy Graham restate it in a slightly different way as well, but it's absolutely true. And as a very final thought before moving away from NIMBLE, I'd just like to thank my colleagues, Lucy Brownlee, my boss, who's a tester from old, who provided a lot of input to the NIMBLE method, Max Parr, and Simon Norrington, who again are both testing practitioners that I work with. So thanks, guys. I'm sharing the blame for that method now with you. So why is it that we see so many new methods appearing? Well, one of the very common causes is the not invented here syndrome. In other words, an organization may have a vested interest in promoting a particular method of its own, or they may reject methods or processes that other organizations or other practitioners are putting forward, in which case it kind of becomes politically correct to work with a specific method, even if sometimes on certain projects it isn't going to be appropriate. Another major reason, and I'm sure that there are a lot of you out there who've bumped into methodologists before, is the issue of practitioner ego. So a lot of people want to do things in their own particular way, and they will produce and enshrine their method, and basically will fight their corner against anybody who tries to suggest that it shouldn't exist or that it should be modified or changed. And as I said, I'm sure a lot of us have bumped into people of this sort. I certainly have. And I can remember way back when I was working at Rational, we had Ivar Jakobsen, Jim Rumbar, and Grady Booch, all very prominent software development and testing methodologists working for the same company through acquisition. And the management were looking to try and get them to produce a unified method, a rational unified process as it came to be known. And I can well remember crazy email threads from various parties saying things like, oh yes, entities, they should be cloud-shaped. Oh no, entities, they've got to be rectangular shapes. And other people say, no, they've got to be squares and they should have shading around the edges. And fundamentally, all of this didn't actually move things forward a great deal, but we did have method wars. I mentioned my book on Agile testing earlier on. This is a great opportunity for me to try and give away a free copy to somebody. I'm going to ask a question. If you guys out there could respond, all the correct answers we get, we'll basically take a draw and send a copy out, maybe more than one copy if I can arrange it. So the question is, if you're ready, what is the difference between a methodologist and a terrorist? So what is the difference between a methodologist and a terrorist? We'll finish this slide off before I give you the answer, which will give you a chance to maybe send some answers in. So the final item on here is lack of time to perform research. All of us as testing professionals are up against it in terms of limited timescales, limited budget, and people chasing us for software. So it's probably no coincidence that it's often easier to go out there and grab some methodology or take what you've done already and put it together into a process rather than actually do some proper research and see what you could be reusing. So what can we do about that? Well, between projects perhaps, or if we have a bit of time to think about it, start doing some research. Google is bizarrely one of my favorite testing tools. Great source of information out there on the internet. Obviously, there's the opportunity to attend conferences, special interest groups like EuroSTAR, Unicom, maybe even the BCS special interest group in testing, the SIGIST. And of course, we can get some useful information out of books on the subject, courses we can take, or even, and I'm guessing I'm probably preaching to the converted with this audience, attending things like webinars. So a very wide variety of places that we should be looking perhaps for stuff to reuse rather than building and enshrining new methods. Nice quote from Jules Renard there. Laziness is nothing more than the habit of having a rest before you get tired. I'm afraid to say that I have to admit that I was very lazy over the weekend in that case. So the answer to the question, what is the difference between a methodologist and a terrorist? Well, you can negotiate with a terrorist. Yeah, sorry about that. I'll get my coat. Moving swiftly on, let's have a look at the Agile experiences in the real world. As I mentioned, I've been very lucky to have had the chance to talked to a number of leading practitioners, and we're talking about C-level executives in organizations. We're talking about test managers, project managers, practitioners on the ground, and also some really great names across the testing industry. So not wishing to name drop, but I'll name a few. People like Steve Allett, Graham Thomas, Tom Gilb, Jeff Thompson, Isabel Evans, Ivar Jakobsen, Bob Bartlett, Duncan Brigginshaw, among some of the people who were kind enough to talk to me about the work they were doing in Agile and to allow me to document some of their case studies. Across, across the projects that I looked at, there are a number of different approaches being documented as well. So things like Scrum, Extreme Programming, Eclipse Way, the Essential Process, the one that Ivar Jakobsen have put together, Rational Unified Process, of course, something I'm very familiar with personally, and also a number of different sizes and types of project environment. So there are case studies which document from the very smallest projects where maybe just 2-3 practitioners are working on the project, all the way up to large-scale projects involving hundreds of practitioners, sometimes working across different sites, and even some of the case studies covering projects which are working across different geographies, so offshore, if you will. All of these really providing some excellent advice and guidance on how they achieved success with their project. But also looking to find out the sorts of problems they were suffering with Agile, the things that they might challenge doing again in later projects, and also to even capture the kind of disaster stuff, so really the good, the bad, and the ugly of their Agile projects. Excuse me. Book, thank goodness, very kindly published by Cambridge University Press. I shan't plug it much. There'll be one more mention at the end, don't worry. I do have a starving daughter and 2 cats to feed, so it is quite important to me. So let's move on. I like the late Dr. Carl Sagan's quote on research. It's absolutely true. In the book, it's summarized in one of the appendices, basically listing the sort of size and complexity of projects versus something like 50+ specific Agile testing practices that were distilled out from the projects within the book. So quite a usable way of presenting those. Also a kind of foundation class, the sort of practices that would be useful across any project. And the stuff we'll look at the end of this presentation is distilled out of that category. So hopefully a set of 8 best practices that you will be able to use on your own project successfully. And on that subject, let's focus in on looking at the starter set of best practices. As we've mentioned, these are kind of foundation Agile best practices distilled out of the things that people were doing successfully on their projects. I can only list 8 here. It would be impossible to cover the 50-odd plus practices in more than a couple of presentations probably. But the key things about these is that they are pragmatic, practical, they're usable, they can be applied on your own projects, and quite importantly as well, we've called them synergistic Agile practices, if that's actually a word. These can be combined together to give more value than each of them on their own. And as we go through each of the individual practices and look at those, what we'll do is list the areas where they overlap and they impact on others of these practices. So combining 2 or more together can bring even greater benefit, in essence, to what we're doing. Specifically, what we'll look at in the next few slides are the necessity of making everybody have access to test process. If we've spent a lot of time and effort capturing our best practices and enshrining them in the process, then we need to make sure that everybody can get sight of that. We'll also look at a technique called test-driven development, where basically the developer will specify the test before they've even developed the code that they're going to be writing as part of the application, and then use that test to check the software they've written. So a very, very powerful, very simple way of helping to drive quality into the project as early as possible. We'll look at a technique for bringing testers together, termed pair testing. Not just tester with tester either, but also the opportunity to bring testers together with other stakeholders in the projects. So again, we talk about driving testing and quality deeper into projects. We could start even by pairing people like testers and analysts to make sure that we start to understand the requirements involved and add some quality input at that stage. Case studies reported success with is continuous integration, and in combination with that, the use of testing. So building the software, having code submitted to the code base by the developers, and then doing a build, and immediately as we've done the build, to do a test. Clearly there's some great benefits involved in identifying defects early and fixing them early in that approach. We'll look at the role of test automation and automation generally in Agile projects. There are a lot of people who will tell you that automation is an anathema, if I could say it properly, anathema to Agile. Oddly, something like 85 to 90% of the case studies reported the use of some sort of automation, whether it be from continuous integration or unit testing, or even through to the higher levels of testing as well. We also need to find effective, novel, interesting ways of reporting defects and also visualizing the problems and the defects themselves. And from the book, some fantastic examples and cases of where people have used a great deal of ingenuity and imagination to find ways that they can basically inform stakeholders within the project that need to know about defects, that there are problems. We'll talk about the need to fix all defects immediately, a very good discipline to use if it can be adopted to prevent a backload of defects building up as the project goes through. We don't want to have late discovery of major problems. That's a great recipe for project overruns, cost overruns, and late delivery of software. As the final best practice, what we'll do is look at what George Santayana there tells us. We don't want to forget lessons of history. We want to capture the good stuff we've done on testing projects to make sure we do it again. We want to capture the bad stuff to make sure we don't repeat our errors again on the same project on later projects. So a very useful approach for making sure that we capture and renew the best practices. Okay, let's kick off and look at each of those individually. So this is all about providing access to test process details. We could have the most brilliant method in the world, the most fantastic testing best practice that's ever been seen, but if we don't give the stakeholders on our projects access to the information about the process, then we've completely wasted our time and effort in putting it together and documenting it. So what this slide is going to argue for is finding simple, effective, pragmatic, and maintainable, sustainable as well, I suppose, approaches for making sure that everybody has access to the process. You won't be surprised to hear, amongst the case studies in the book, there were numerous examples of projects where different approaches, different techniques were used to provide process access. So Ivar Jakobsen, in their essential process, the ESUP, they have a very neat way and a very simple, very pragmatic, very practical way of delivering best practices to the stakeholders on the project. Now, the project they described was a very large government project with lots of stakeholders working in different parts of the project, sometimes in different sites. So essential to make sure that everybody was reading from the same hymn book, if you like. Their solution was not just providing an online reference as process, but also having A4 size, double-sided, laminated reference cards which described particular tasks and the process needed by the practitioners to be successful. So, for example, there would be a card for unit testing, there would be a card for functional testing, for performance testing. And as the different practitioners got to the stage of the project where they needed to know about the particular key parts of the process, they would be given copies of these reference cards. It's a very neat solution, not massively expensive. Obviously, you have to print these things, and maybe if you're feeling particularly extravagant, laminate them, I suppose, if you've got kind of reuse in mind and durability. But a neat way of getting information, specific information, targeted information out to particular people on the project. Clearly, if we're printing stuff, we have to be very cautious to make sure that we are working with up-to-date current copies of the process. I mean, if there are changes to the process, we must have an approach in place which allows us to reprint and redistribute these cards if necessary. So that's one thing you have to watch out for. Good change management and good version management is kind of key to that approach. That said, I still think it's a really neat way of doing it. Another approach which doesn't have that same problem about currency of the method is using an online distributed solution. So, and I make no apologies for this, rational unified process, having come from a rational background, is one I know very well. There are others out there, of course, and don't forget, use my favorite testing tool, Google, to have a look around to see what you can find. But in the unified process, what we have is a web-based process which is delivered onto people's workstations, onto their laptops, which allows people to understand what roles there are, what the responsibilities for the roles are, what tasks need to be completed, the order they need to be completed in, the artifacts, the inputs, the outputs to the tasks, the deliverables. All of those things are documented in a very neat, a very rich, hyperlinked type solution. And of course, as we just mentioned, keeping it up to date is not so difficult because we can make changes to the process and we can publish them back online in such a way that everybody gets to see the most up-to-date version of those. We still need to be thinking about good configuration and change management, though, because as we'll argue later, in a later slide, I think it's key to understand where changes have come from, who proposed them, and who basically signed them off, and why they did make the change. All of that would be quite valuable information to have. Another approach, which is very powerful for where we have projects spread across different sites or even offshored, is to use a tool which, by using the tool, actually informs of the process. So again, I'm going to rely on a couple of my own favorites which I have used. Rational Team Concept, Rational Quality Manager are both tools of this sort. They're both a related pair. Team Concept for the development side of a project, Quality Manager for the quality management side, you won't be surprised to hear. These products contain their own built-in workflows. So if you receive a task from a manager and you decide to make an estimate of how long it's going to take to do, you feed that back, it's recorded into the timescales and the project plan. All of these things basically are part of the process, and in using the tool, you're in fact adopting and following that process. Process enforcement sounds a bit dictatorial, but the reality is that what we have is a fantastic way to entire project, whether they're co-located in different sites, whether they're offshored, are by using these tools following the process. And of course, and I should have mentioned this as well for for online solutions, these things need to be customizable. You need to be able to introduce your own specific requirements to the process and have those maintained. Another major issue that we're going to face in making sure people have access to the process is to ensure that where there are changes, and sometimes changes may be major ones in terms of how you use the process, make sure that there is good training available. It's no good making a major change to your method and then not telling anybody, and everybody, although they have access to it, doesn't actually understand what they're supposed to be doing. So combination of good access to process, but additionally making sure that everybody receives the correct training and is updated. Process nurturing as well, very valuable to have mentors, to have people available who they can talk to, who they can consult as well on using it. So that's a very powerful way of helping to support the use. In terms of synergy, test process, I have to say, touches all of the best practices, I guess, but I've kind of, to be consistent, I suppose, I've identified pair testing, visualization, and lessons learned. I guess you can see the links between those and good process use. Okay, next to best practice, adopt test-driven development. As I mentioned in the introduction, a very neat, very effective solution where the developer specifies the test that's required before they develop the code, and then after having developed the code, apply the tests to confirm that all is well, they have no defects, it does what it's supposed to do. So in this case, we have a kind of a virtuous circle. If we find that we have to change the code, we can refactor, and we can then go back through the test process and make sure it works. In the case studies, very, very high percentage of the case studies supported the kind of importance of unit testing and developer level testing for driving quality through into the project. Also, why wouldn't you want to do this? I mean, the approach is excellent because the developer has to have gained a fundamental understanding of the requirements for the functionality they're developing ahead of actually writing the code, you know, and surely this is absolutely part of what we want to do in terms of producing the right sort of solutions. So Ken Beck, who is the father of extreme programming, his view was that this approach encourages simple designs and inspires confidence. I think as well you can add to that help to drive forward into the project. And again, from case studies, the results, the reporting from those is that this is an effective solution to use as a best practice. So where does this one synergize, if I can use that whole word again? Well, if we're running an integrate and test approach, every time new code is submitted, we can do a build and then test the code, helping us to identify and isolate problems quickly as they arise. Using novel and good techniques to visualize and highlight problems quickly will also integrate between those two. And if we're following a fixed defects immediately approach, then we can identify, understand, and correct the defect more quickly if we're following this sort of an approach. All right, pair testing. I desperately looked around on the internet for a graphic that would kind of give me something that looked like pair testing, and I've ended up with a pair sitting on top of a pair of weighing scales. I'm sorry. Sometimes you just can't find the graphics. This approach hinges on the idea, I suppose, you know, the old idea that two heads are better than one. So what we're doing here is bringing a tester together, not necessarily just with a tester to help in terms of designing, executing tests, but also looking to bring together testers with perhaps programmers, the user community, and even the analysts on the project. So again, helping to drive quality deeper into the project, I suppose, would be another one of the good side effects of doing this. If anybody's familiar with XP, XP already has a practice which it terms pair programming, which is bringing two programmers together. I find this to be a really powerful solution for helping empathy with projects as well. So where testers and programmers have been paired in the case studies, some excellent reporting of success where even after a project is finished, programmers will go back to the tester they were programmed with to consult them about quality issues. Downside of this is you have to be very careful. You don't want the programmer to basically perceive the tester, if they're being paired with the tester, as the kind of QA police. They're not there to kind of enforce and legislate for good quality. They're there to help the programmer and vice versa as well. So done properly, there is in fact a certain empathy where both programmer and tester gain a better understanding of each other's roles and their benefits. Bean counters as well, you may have to convince somebody who's got the budget for a project why you're using two people instead of why you could be using one person on a role that looks like it can be done by one person. That's a tricky one, but I suppose you have to sell the value of what's happening in terms of better quality, improvements in productivity, and defects, I suppose. I've had some good experiences personally of this. I was involved some years back with putting quality management system in place for the Wine Society in Stevenage, and they have a really neat program where they rotate the user community of the stuff of the systems that they write in house through the testing team. And it was very obvious that the users on the one hand were getting a much better understanding of what the testers were doing and the reasons they were doing it, and not just assuming that these were a bunch of people who were slowing down their access to new code. Similarly, having genuine real-world users on hand to help the testers in terms of specifying and executing tests and understanding the defects was a very, very valuable thing as well. So an interesting technique, challenging perhaps to implement in an organization, particularly where you've got very small team numbers, but still nevertheless something which the case studies report good results with. Excuse me. Okay, we've talked about continuous integration and test previously. We'll look at it in a bit more detail here. So this process, which pretty much has to be supported by some form of automation, basically takes code as it's developed by the developers and added into the code base and builds the software using the continuous integration solution. And as the code is produced, tests are executed against it. So these could be unit tests being reused, perhaps. They could also be functional tests, maybe even some performance tests put in to the system to run against the code. So the benefit of this is that as we start to submit code into the code base to build the system, we highlight defects straight away. So good visualization of problems and good reporting, clearly something which needs to be supported in this approach. Benefits of that, well, hopefully we can localize and identify the problem much more easily because we know what we've just done in terms of submitting code to the code base as we've done it. We have to look at adopting a fixed defects immediately approach to this so that as the defects are identified, work out what the problem is, fix the code, rerun the tests, and make progress. As we said already, it will require some moderation, some level of automation, whether it be just supporting the build process, but also potentially in a kind of fully realized version of this, automated tests being run as well. There are some great roles for clever, novel visualization of problems in this approach, and we'll come back to those in a slide or two's time. Test automation. I think I mentioned that a very large percentage of the case studies reported the successful role and use of automated testing, whether that was down at developer level, where pretty much every case study that talked about developer level testing reported on use of tools, or moving up through the testing process on integration, functional performance testing. If we're using, as we said, a continuous build approach, then automation is clearly necessary, but also integration with tests, automated tests, gives us a lot more synergy again. We can have a look at using capture replay tools, and they can save time, effort, and cost. However, don't necessarily believe every salesman who tells you that they're easy peasy lemon squeezy and they're the kind of universal panacea for testing. If you have projects where you have lots of builds and lots of releases, if you've got large, complicated code bases, if you have a lot of people involved in the process and you need extensive regression testing, they can be a valuable tool to use. If you're looking at small projects, if you're looking at one-off development projects, low complexity, they may not be justifiable. But you have to basically look at each project and take it on its own merits and challenge their use, in effect. Even where you've got test automation, it may not actually work out brilliantly for you. There's a great case study by a guy called John Tilt in the book. He is the project manager, test manager for a massive middleware project. They were taking 2 to 3 weeks to manually regression test this system, which had a number of new releases, pretty much annually. Even with capture replay tools and something like 35,000 tests, the testing was still taking something of the order of 10 days to complete. Unbelievable numbers. Laser-guided testing was the approach that John and his team adopted to help make even that process more effective and more efficient. And basically, without trying to read the chapter to you, basically John and his team pulled together things like metrics on reliability, knowledge of the structure of the application they were building and the modules, statistical and probabilistic elements, mathematics, and bringing these together, he produced a system which would assess automatically where the bulk of tests should be reruns for any given regression test. So an absolutely ingenious way of squeezing even more effectiveness and efficiency out of it. I think from 10 days, it's still pretty impressive. It's down to about 10 hours, I think, now to do a regression test for this particular very large application. But a great story. Synergy here, well, integrating tests we've mentioned, automation has a role there. Products which give good reporting, good visualization of the defects so that we know we found them and we find them quickly will be important, and also adopting a fix all defects immediately approach clearly will bring some benefits in automation. Okay, effective reporting and visualization of defects. This is probably one of my favorite parts of the presentation. What we have here is a graphic involving lava lamps. You're probably thinking, what the heck has John put lava lamps on a slide for? We'll come back to that. So, if we've done our testing and we've found the defects, and we've spent a lot of time, effort, and money doing so, we better make sure we have an effective way of making people in the team aware there's a defect. We must highlight those defects to the right people, to the right stakeholders, as quickly as possible. If we can be looking at, we certainly don't want to have late discovery of defects. So, innovative, clever, ingenious solutions are going to be very valuable here. And there have been some great ones reported in the case studies. So, real-time online dashboards, obviously something which Agile does talk about and recommend. But things also like instant messaging systems, and even if we've got an automated integration and test solution, I think Dave Evans from SQS had reported that they had a clever integration engineer who'd set up a link to basically text stakeholders when problems were found. Very neat. And finally, lava lamps. So, what's a lava lamp got to do with testing? Well, again, another one of the things that Dave Evans reported was setting up an automated integration and test system which was also wired up to a pair of lava lamps, one red, one green. Whilst the project was happy, whilst builds were coming in, they were tested and everything was going successfully, green lava lamps sat there in the middle of the project, bubbling away merrily, and everybody was happy. As soon as a build occurred which detected a problem, the lava lamp would switch off, the red lava lamp would switch on, and people would be galvanized into action to actually find out what the problem was and try and get it fixed. And I think that's really really quite neat, probably because I'm old and I remember lava lamps when they first came out. But a fantastic side effect has come out of this. Dave Evans reports that there was a level of project pride which said as soon as that red lava lamp came on, they would find and fix the defect before the wax actually melted. So quite incredible idea that even the way of visualizing the problem had its own benefits in terms of making people determined to get to the bottom of the defect and fix it. Fantastic. So, integration with integrate and test, obviously. Test automation has to be a part of the solution, and of course finding the problems and fixing them, so fix defects immediately. Which takes us on to fix all defects immediately. As we said throughout the presentation, we don't want to have a backlog of defects building up. Firstly, that provides us with all sorts of issues in terms of triaging problems, fixing problems, potentially losing problems and defects. And of course, most of us have probably seen software that's been released where a defect was found, but for whatever reason it never actually made it to the right people to be fixed. That generally annoys customers. And similarly, if you've reported a defect after delivery and you find it doesn't get fixed in the next release, again, generally doesn't impress the customer. So following this approach, once we find a defect, activity stops, focusing on working out what the problem is with the defect, tracking the problem down, correcting the defect, and then retesting the software to make sure that we have fixed the problem, but also that we haven't introduced other issues as well. So a little bit of regression testing there too. If we can follow an approach like this, then what we have is a good solution for avoiding late discovery of defects, for losing defects, again, not a great idea, and really helping us to keep a handle on our delivery time scales for the software. With integrate, well, integrate and test, obviously. Test automation will be a useful tool to help us identify and report on problems, and good visualization, as we discussed in the last slide, can be useful for understanding or highlighting the problem, getting to the bottom of it, and then fixing it. Okay, final one of the best practices. Don't forget the lessons of history. Another one of my very favorite internet images I found of an elephant wondering why there's a bit of string tied around his finger. Small things please me, especially when I'm putting presentations together, don't worry. So what are the key issues here? Well, we absolutely want to make sure that we learn from experience. If we found a particular practice that works for us, works for the project, then talk about it, capture it, document it, reuse it, spread it to other people. But conversely, if we find that there are issues we've encountered on the project, we'll also want to capture those, because we won't want to make the same mistake again. And similarly, we want other people, perhaps we're working with, different parts of the organization, to also know about those issues we've picked up. How do we do that? Well, classically in an Agile project, lots of communication. So retrospectives, basically, small close-down meetings, if you will, where we, in a very short, sharp, focused way, collect everybody's input, understand the good, the bad, and the ugly, make sure we document it, make sure we roll it out for future. Good communications are absolutely crucial to this, and everybody's perspective is definitely important. Isabel Evans, God bless her, provides a fantastic case study about effective communications in projects, and we'll all have seen this as well. We have to avoid a situation where One very forthright person basically hijacks the entire meeting because they're talking and they want to get their point across, where we know for sure that some of the quieter, more reflective people in that meeting have got some really valuable input to provide, but aren't going to get a chance to do it. So Isabel talks about exactly those challenges in her case study. She talks about some fantastic practical solutions you can use. De Bono's hats in a meeting, Ishihara fishbone diagrams, Weaver triangles, a whole load of really practical, useful things to make sure everybody has input. If we've highlighted the good, the bad, and the ugly, then we'll need to make sure we edit, change, update the process as needed. And of course, as we discussed before, make sure that we disseminate those changes so that everybody in the project is aware of what we're doing in terms of the good stuff and the bad stuff. So synergy is absolutely key with all of the practices. Anything good we spot on the project that we want to capture, document, and reinforce, we should be looking at doing here. Okay, with my 45 minutes nearly up, that takes us very nicely on to summary and conclusions. So, in summary, it's absolutely key to what we've discussed and talked about today to say that there is no one-size-fits-all test process. Every organization is going to be different, from different sized projects with different complexities, with their own budgets, challenging timescales, lack of resources, people on the team with different skill levels and application determination, different reasons why we produce software, whether it's for use in-house, whether we're producing bespoke software for a customer, whether we're producing off-the-shelf products. All of these things will have an impact on what we do test process-wise. I've left project politics till last here because I've got a really shocking anecdote to tell you about a guy called Nick Denning, who again was one of the chaps who provided a case study. He was the MD of a fairly significant software consultancy. They were called in by a merchant bank to try and fix problems where the user base for software developed within the bank were reporting lots and lots of problems when the software is being delivered to them. It turned out that the developers, and also I guess the testers in the organization, were getting bonuses based on lack of defects being detected. Now, users reporting problems wasn't impacting that as features of the software. Some automated testing tools to capture replay very quickly started to find lots of defects in the software and reporting them back to the developers. So immediately, their bonuses are starting to be eroded by the fact that real defects are being found. So this continued for a few months, but then suddenly, all of the defects dried up. So Nick was thinking, this is fantastic, we've improved quality, this is to help the developers. Unfortunately, the users started to find the same sorts of problems, the features, when the code was actually delivered to them. On investigating, it turned out the developers had actually discovered what testing tool Nick and his team were using. They had clubbed together, bought a copy of that testing tool, and they were using it alongside the code they were developing to make sure that the code basically defeated the way the testing tool worked. So we talk about politics, but in this case, we literally kind of had trench warfare going on in the organization. So fascinating example of not getting on. Finally, on this slide, whatever you do in terms of best practices and processes, you have to use your knowledge, your experience, and of course, your common sense to tailor what you do and how you do it. Finally, in summary, it's absolute truism that testers are under increasing pressure to be as effective and efficient as possible. So the very last thing I would suggest that we can afford to do is continue to reinvent the wheel. What we need to do is have a look at what's out there and look at what works pragmatically and practically at the moment. So there are lots of agile approaches that we could look at. Do some research. Watch out for ego wars. Don't necessarily limit your choices. There are lots of projects and people out there doing agile. Consult and research widely. Also, Jeff Thompson, in his case study, reported some very valuable reuse of, if you like, old school testing practices, which he and his team had incorporated into their testing project. In fact, as it turned out, producing a much better result than an external agile testing consultancy who were also brought in to work in parallel with them, who apparently failed miserably to improve the quality of the software. As we said, there are lots of agile practices in the case studies we've talked about that could be used successfully. This is my one pitch for buying the book. If you would like to read more about the 50-odd plus practices that the book extracts, but also reading the case studies themselves, I think is very valuable, please don't hesitate to rush out and buy my book. I get it now. If you go onto Amazon and you do a search on Agile Watkins, Agile Watkins, anybody that's seen me play five-a-side football will know how stupid that pairing of words is. You should find Kindle, softback, and hardback copies. Finally, introducing agile methods and best practices can be pretty challenging depending on the kind of level of maturity and traditional testing in your organization. But the case studies and the book in general seems to suggest that the results can be positive and rewarding. So the suggestion here is absolutely to persevere. There is guidance and proposals on how you introduce, roll out, adopt Agile within the last chapters of the book. And on that note, I shall say thank you very much for having the patience to listen to the presentation. And I think questions are moderated through Paul. And I understand as well, if there are any questions we can't cover off now, then we will cover them off by social media later.
That's right, John. Yeah, thanks very much for an excellent presentation. As you mentioned, we'll now take questions. If anybody has a question, please type it into the control panel on your right-hand side there, and I'll put the questions to John. Just while we're waiting for questions to come through there, I'll just remind people that it's now less than 3 weeks to go to the EuroSTAR Software Testing Conference, which takes place in Amsterdam. If you are planning to make a booking for that, remember to avail of our group booking discount, where if you book 4 places, you get a 5th place free. The first question coming through here, John, is from Jeroen Mengerink. How would you suggest that we visualize defects?
Hi. So how do we visualize defects? Well, I guess historically, traditionally, we've written up bug reports and we've documented them using paper and pen. The more kind of enlightened view, I suppose, is to look at using some sort of automation. And almost every single testing tool that you can use out there on the market will provide a test log. And generally speaking, if the tool is worth its salt at all, the test report will tie the problem back to the test case that was the design for the test. From the test case, you should be able to backtrack to the code and the requirement, and using that traceability, you should be able to understand the defect in more detail and its importance and impact. So automated test logs will be a useful approach. In an agile kind of a view, as we've seen on the presentation, but also from the case studies, the only limitation here is people's imagination and ingenuity. I mean, we talked about the lava lamps. You know, who thought of that as a solution for highlighting a defect? Sure, the lava lamp doesn't actually tell you what the problem was or where in the code the defect was found. However, what it does do is if we're following an integration and test approach, it highlights that the most recent addition to the code base was something that kicked off the problem, whether it was within the piece of code itself or whether it caused a defect somewhere else in the application, depending on how modular, how well encapsulated the code is. We still have a fantastic starting point to begin the process of actually looking into the code base to find the problem. So my suggestion here is there are lots of very clever, very neat ways of tracking defects out there. But don't be afraid to try and use your imagination, and don't be afraid to try some clever approaches.
This is probably a good follow-on question, John, from Dennis Gauthier. Beyond defects visualization, shouldn't we go further to identify impacted requirements?
Yeah, absolutely. Yeah, that's absolutely a solid point. And I think I just mentioned in the answer then, if we're looking for a testing reporting solution, and particularly if it's supported by automation, then what we have to look for are solutions that allow us to trace back from the defect through the tests, back to the design, back to the requirements involved, so that at any point we can assess the importance of the feature that we've discovered has failed, but also we can pick up information about the likely priority for getting it fixed, the likely impact on other parts of the application if we don't fix it, and really have a much more informed decision that we can make about what we do with the defect. Sure, some of these, the defects we find may be trivial, some may be really kind of deep impact ones. It's really difficult to, because I mean I very glibly talk about fix all defects immediately, like everybody could actually do that in a project. I have to say that it's a great approach to try and follow in an agile project, agile testing project. But if you find a major defect which has a fantastically deep impact, which is likely to have cost implications and overall implications, then you may well have to focus on that at the expense of maybe less important defects. So, as I said at the end, you've got to be flexible with agile approaches and practices, and you may well have to fall back on more traditional sort of triage type techniques in testing to sort out some defects.
Rainer Dewson asks,
So hopefully that answers that question.
Are there different test methods required or recommended when switching from traditional to agile testing?
Are there different test methods? I think there's some fundamental differences, and I'll come back to tell you why I think why this is wrong. The stuff I'm going to tell you why it's wrong in a second. I mean, historically, we've always talked about Waterfall style projects. We've always talked about late testing. We've always talked about late detections of defects and holding on to risk throughout the project. Agile clearly is talking about iterative methods, shorter timescales, more involvement with stakeholders. So immediately, there's a kind of a difference in terms of, if you like, the kind of life cycle of the development and the testing. Now, the reason I say that may be wrong comes back to the point I made about you shouldn't throw the baby out with the bathwater. You should also look where it's appropriate to reuse traditional approaches. In Jeff Thompson's case study, it's a fascinating one. I think I mentioned briefly, it has two separate streams doing the same sort of testing for a customer. One is an external consultancy which claims to be absolutely agile and to adopt all the agile methods and processes. The internal one, which Jeff is working on, is more, in quotes, traditional. They have a waterfall style approach. They do things in a slightly different way. The result, though, is crazy. The Agile project doesn't deliver, doesn't come in on time, doesn't come in on budget, fails to improve the quality of what it's testing, whereas the traditional, if you like, testing project does everything right. However, when Jeff actually analysed this, he did say, okay, so we were all co-located. We actually all had really good communications, but we did follow a waterfall style approach. But within the waterfall, in fact, we did little iterations. So, funnily enough, Jeff's claim that he was running a kind of a traditional approach on analysis, on him looking at it in more detail, turned out to be actually quite agile. Whereas they never ever found out what the consultancy was doing, because they refused basically to let anybody see their documentation or reports or anything. So we'll actually never know if they were doing agile at all. So yeah, there are differences, and I would say maybe 75 to 80% of the differences are about good communications. Agile talks about where we can co-locating all of the stakeholders. It talks about having rich communications infrastructure in place so people can share information, they can share objects and artifacts, things like test plans and tests between themselves very easily. It talks about effective stand-up meetings at the beginning of the day to understand what you're trying to do that day, what might get in the way, what we're looking to do later. It has things like agile retrospectives, where people get together at the end of tasks, at the end of projects, and talk about what happened and capture it. But then again, I kind of stand on my traditional soapbox, and I say, well, surely the very best project anyway have always communicated well, and they've always had lots of meetings, and they've always captured information about what went right, what went wrong. So it's a difficult question to answer. I think emphasis is the key thing. I think iteration over waterfall. I think communications over maybe more dysfunctional projects. I think co-location over people being distributed. But even then, I've seen case studies of offshore testing projects that have gone really well, having been run under an agile approach. If I've got a second, Paul, I'm just going to say I think as well, if I can just say this, I think agile probably fundamentally is just taking the stuff that really good practitioners have always done in the past and been successful with, and kind of enshrining them and wrapping them up in a new name, perhaps. I have this theory as well about object orientation as an approach. People who have adopted object orientation, they're actually just really doing the sorts of things that good software engineers used to do anyway. Information hiding, encapsulation, modularity, simple interfaces with messages. So maybe actually, maybe this is the kind of deep philosophical thing to take away from the presentation, if I'm not sounding too pretentious by saying that. Maybe the thing to say is that Agile actually pulls together maybe just some of the things that the best people in testing and in project management have done anyway over the years. So that's a pretty contentious endpoint for that answer.
We still have a handful of questions to get through, so we might save those for the EuroSTAR blog.
Okay, that's cool.
Just on your
okay, that's good. Yeah, I could do that too.
Just on your question that you asked earlier on, there were several correct answers, but the first one in was Jorgen Svensson, so Jorgen wins the book. Jorgen, if you can supply us with your contact details, we'll pass them on to John, who can organise getting the copy of his book to you. Thanks again to John for a great presentation, and thanks also to everybody who attended. John, you have something to add?
Yeah, I was just going to say, if capture the second person as well, we'll send them a copy of my book on software methodology.
Okay, the second one, the second name on the list is Jeroen Mengerink, so we'll include him.
It's going to cost me a fortune in airmail, isn't it, if these people are from abroad.
Maybe send it.
It was a pleasure. I hope everybody enjoyed it.
Thanks very much. We'll let you go, John, and thanks to everybody else who attended. This webinar has now concluded.